Hey everybody, and welcome back to Jim's Garage. Today I'm going to show you how to deploy Docker Swarm with highly available storage. This, like many of my other videos, will be a single click installation script across 5 nodes, and I also have a script for 3 nodes. And by the end of this video you'll have Portainer up and running automatically where you can manage your swarm. So you might be thinking, why do I want to use Docker Swarm? Well, Docker Swarm sits nicely between having Docker and having Kubernetes. And if you've been watching my videos now, you know that I run Kubernetes and I've done a ton of videos on that, and you can go and deploy those clusters if you want. But for some people, they're not ready for Kubernetes yet, and arguably Swarm still has a place in the homelab space. That's because typically Swarm is a lot simpler to set up. It has many of the benefits of Kubernetes, and it's a lot lighter on resources. So in this video, I'm going to give you a quick whistle-stop tour of what Docker Swarm is. I'm going to show you all the steps within my installation script because it covers all of the things you would have to do manually. I'll briefly touch on the highly available storage and how we're going to action that. And then I'm going to show you the actual deployment process and log in with Portainer and show you how you can manage your Swarm and also deploy additional services. One of the key benefits of having Swarm over a standalone Docker installation is that you can perform maintenance on that virtual machine or even on the host that it resides on. So that means that you can reboot due to updates or installation of new hardware, and you won't lose access to all of your services. Those will fail over and replicate onto the other nodes within the cluster, and especially if those are on different physical machines, you should have some high availability. Which is great if you're doing things like you want your Pi-hole to still be up and running. That can fail over to another node and still be up and running. One of the key things for doing that is having highly available storage. You're probably used to using a single Docker host where you have bind mounts or volumes, but the issue with those is locality. Those are located on that specific node, and thus if a service were to fail over to another node within the cluster, it wouldn't have access to that data. Now in Kubernetes, there's lots of different ways of solving this, but in Docker Swarm, it's a little bit of a less mature ecosystem. I'll come on to that in a minute. But to do this, I've used GlusterFS, which is basically a distributed file system that has replication across the nodes. So effectively, we set up the same folder structure across the 5 virtual machines, and it syncs all of those files in virtually real time to make sure that when a file is written, it's replicated to all of our nodes. Thus, when a service fails over to a different node, it has that data locally available. So it's as if to that container, nothing has changed. Now, as I alluded to, Docker Swarm isn't very popular anymore. That's because it's been ultimately superseded by Kubernetes. But I still think there's a place for it in the home lab, and it's going to give you some high availability due to the overlay network it creates. And thankfully in Docker Swarm, this is really straightforward. In Kubernetes, it's a bit more involved. You have to have things like VIPs and load balancers and ingressors and all of that stuff. In Docker Swarm, that's a lot simpler. We simply have ingressors and overlays, but they're all automatically declared in the installation process, so you don't have to worry too much about it. And so if we have a quick look at a typical topology of Docker Swarm versus Kubernetes, you can see that it's drastically simpler. And that's why there are fewer resources and it's easier to maintain, and why this might be the perfect setup to give you high availability in your home lab with easier maintenance, fewer system requirements, and possibly even that halfway house, getting comfortable with clusters, etc. before you move on to Kubernetes. So without further ado, let's jump into the script and let's see what it does. So if we look at the code, the first thing I want to point out is that I've got 2 setups for this. The one I'm going to show you is using 5 virtual machines, but I do also have a version with 3 virtual machines. Now, for those of you who aren't familiar with this kind of setup and why do I want to have 1 virtual machine versus 3 or 5, it's a good question. Because we're having a cluster setup, you're going to need more than 1 virtual machine, but that's how we realize the benefits of having a cluster. So in a 3 setup, you basically have 1 manager. For Kubernetes folk, that will be the master, and you'll have 2 workers. Now, this doesn't give you any failover. if the manager goes down, but it does still give you failover if one of your workers goes down. And depending on how you have your network set up and what resources you've got available, maybe a 1 manager to 2 workers makes sense. A better approach would be to have 5. And in that case, you would have 3 managers and 2 workers. And you can extrapolate this as large as you want to. There isn't really a limit to this. Within that setup, you have 3 managers. So one of those can fail and the cluster will still be up and running. And one of your workers could fail as well. So then you would have 3 out of your 5 and your cluster would still be working. Now let's get on to a review of the script. This is very similar to some of my Kubernetes scripts, and I've done that deliberately. Now, how this works is there'll be 5 nodes within the cluster, and you'll use some other machine, another virtual machine, or your Windows terminal, or whatever you want to do to run this script. I've done that deliberately because I like to keep the management outside of the cluster, albeit that's not strictly true because I've got Portainer running in here, but that's a separate issue. So just looking through the script, you just need to do this section here. You should only need to edit this section, and that goes down to here. So it really is pretty minimal. So in here, you've got the admin. So this is the machine that you're going to run the script on, and I'll show you that in a minute. And then the rest here are your 3 managers and your 2 workers. I've just put this onto my VLAN, which happens to be the 3 VLAN, and I've got those in sequential IP addresses. After that, I've named my 2 worker nodes. So these are Docker Swarm 04 and Docker Swarm 05. And this is probably a good point to show you how I have this set up within Proxmox. So looking at my Proxmox cluster, you can see here that I've got Docker Swarm 1, 2, 3, 4, 5. Ignore the ordering. I created these after because I tested the first with 3 and then I tested again with 5. And also up here, I did some earlier testing. But these are the 5 that we're going to connect to here. Now, having a quick glance at what these are, you can see the hardware here. These are using Cloud Init. This is Ubuntu version 23.04. I've also tested this with all mainstream Ubuntus and it works. For anyone who watched my live stream, the issue I had there was I was using the KVM image and the overlay network did not like the KVM image. I'm not sure why. I've put a ticket in. Hopefully I'll find an answer to that. But in terms of hardware, pretty straightforward. These have just got 4 gigs and 4 cores and they've got 10 gigs of space. You can obviously change this to whatever you want, but do bear in mind that you might need to change the default hard drive space just because it defaults to about 3 gigs, which is going to cause you problems. So once you've got something similar to this setup and you note down the IP addresses, you can then head into the script and you can edit your values here to match. The Docker Swarm 04 and 05 are taken from those names within my Proxmox, so you can see them here, and that's all there is to it. In here, I've set up the user for Ubuntu, and this is the value that I populated within the Cloud Init. The interface is ETH0, Ethernet 0. That's what the default is for Ubuntu. And then there's some arrays here, and these are the arrays that will allow you to expand this to whatever you want. So for example, if you wanted, I don't know, 5 managers and 3 workers, you could add in more here. You could add them to these respective arrays and you should just be able to run the script. The final part, and this is a little bit what catches people out, is the certificate name. So for my demonstrations, I'm just using the default certificate that is in Proxmox, so when Proxmox is created. And what that looks like is over here on my Docker Swarm. If I go to my Cloud Init and I double click my public key, it's this value here, which you should be able to find in your node. And then if you go onto the certificates, you can find that in here. So that's all I've done here. I've simply added that into this part here. I've downloaded that locally, and then we're going to use that in the rest of the script. I'll show you that in a moment. So just getting into what the script is actually going to do. So firstly, it's going to take those certificates that we've added. We'll be copying those to our admin machine in a moment, and it's going to copy them into the SSH folder, and that will allow the admin machine to do SSH connections to all of the other nodes within our 2B cluster. It's just going to accept them, so it doesn't give us a warning message, and then it's going to copy all of the keys to the first master node. That's because the first master node, the manager, is where we initialize the cluster for Docker Swarm. Once we've done that, it's going to go through each of the nodes. So this is all of the managers and all of the workers, and it's going to do a few things. Firstly, it's going to set all the firewall rules off. This isn't typically needed. It was just for testing. I didn't want to get things in the way. You should be able to delete this or tweak it just to the ports that are required for Docker Swarm. Then it's going to add Docker. So we need to download and install Docker onto every single node. So this is just pulling the keys, the key rings, etc., and installing Docker via the recommended method. Once it's installed Docker, it's then going to install GlusterFS. Now, if you remember at the start of the video, this is how we get highly available storage. Once it's done that, it's going to start Gluster and then enable it so that every time it boots up, Gluster is loaded. And then it's going to create this directory here, which is where we're going to host our Gluster files to be mounted later on in the script. Once we've done that, we're going to connect to our first node. This is that manager 1, using our certificate, and we're going to initialize the swarm, so init. And it's going to advertise the manager 1's IP address so that other nodes, the ones that we're going to connect later, can connect to this one. Now, what happens is when you initialize a swarm, it creates 2 tokens. And those 2 tokens are here. We've got a manager token and we've got a worker token. And now what happens there is I output the manager token and the worker token just to a text file. And then I'm going to copy those text files over to the admin. Remember, the admin is where we're running this command. And then we set the variables to those tokens so that we can specify them later. Next, we're going to connect the other 2 managers, the 2B managers, and it's pretty much exactly the same process. We connect to each within a loop. We then specify the manager token, this one here, which is the one that this command up here spat out. And then this will join that manager to the cluster, and it will do that for both managers. Once we've done that, we do exactly the same process, but we do it for the workers. So exactly the same as before, just this time we specify the worker token. So then by the end of this, we've got 3 managers and we've got 2 workers. Next, we're then going to create the actual GlusterFS. So to do that, we connect to the manager. So this is the first one. This is kind of the master manager. And we do a Gluster peer probe. Now, this probes all of the 2B cluster members and basically says, hey, join my cluster, get ready. Next, we then create the actual staging volume. So this is the volume that's going to be used and shared across all the nodes. We set the replica to 5 because we're going to replicate this 5 times. So a copy of this on every single node. And then we just specify the requisite IP addresses of each one and then the location. And these are all the same across them. Once those are created, we can then start it. So it's called staging GFS. You can actually change that to whatever you want, but just keep it the same for ease. Once we've done that, I've just added some labels to my nodes, specifically the worker nodes. And what that means is when we come to spin up a service, that's the same as deploying a container, we can actually specify just to deploy on the worker nodes. And that's helpful because typically your worker nodes will have more RAM, more CPU, etc. And that makes sense to then deploy your services onto those. Once we've done that, we connect to every machine in the cluster. Remember, this is now in a cluster. And all that we're doing on this part here is making sure that when the machine reboots, it automatically remounts our Gluster file system. So that means that after a successful reboot, it should have access to all of the files and thus is then part of the cluster. And also containers can then fail over onto that new node. The last thing in the script is basically for ease, and you can delete this if you want. The key thing here is replicate this for whatever you want to use, because basically we're making a new directory in our /mount folder, and the /mount is where I have the Gluster mounted to. So basically anything we create now in the /mount folder will be replicated across all 5 nodes. It's really that simple, which is awesome. So this creates the Portainer folder. That's magically then created across all 5 nodes. I then pull down this Portainer stack here. Now this is just the stack created for Portainer. It's from the official website. It's just changed to specify this location for the volume. So it's not using a Docker volume, it's using a bind mount. And because we've got a bind mount set up tied to GlusterFS, Portainer is then replicated across all of our nodes. So if one of the managers goes down, it can spin up on another manager and it's still got all of the data we had. So it's got your username, password stored, etc. So you can authenticate and log in. The final thing it does is then goes and deploys Portainer using that configuration file. And then it's just some convenience things. So it's going to spit out all of the nodes that are in your cluster. It's going to show the service, which is just this one here, Portainer plus the agents. And then it's going to show the actual pool as well for Gluster. So all of the 5 nodes should be here as a Gluster pool. So to get this working, I firstly connect to my master. This is the master. So here I've still got it labeled as RKE2 from my Kubernetes videos, but this is that 3.5 which you saw specified up here. So this is my admin one. So if I log in here, you can see that I've already copied over the swarm.sh file. So that's this here. I've just copy and pasted that into this folder here. This is just my home directory. And I've also copied across my 2 keys. Now these are my Proxmox keys that are going to be required on what I showed you earlier for the SSH connection. So all you need to do once you copy this over, make sure you go to properties, make sure it's executable, then fire up your terminal and you should be able to get this up and running. You don't need to run this as root. If you do run it as root, it's going to break it because all the permissions are based upon the home folder of the Ubuntu user in my case, but whatever user you specify here. So to get this up and running, we're just going to do the /swarm and then hit return. And now that's going to go through and pull everything that I've just spoken about in the script walkthrough. So you can see here it's copying keys, it's now connected to the first node, and it's now downloading and installing Docker. I'm going to skip ahead in this video and see you on the other side. And hopefully this will have completed, and then you'll see all of the printouts, so things like the service, the nodes, and the Gluster pool. And fingers crossed, we should have Portainer up and running. I'll see you soon. And so now we're at the end of the script. And as you can see on screen, we've got a Docker Swarm up and running. We've got 3 managers here. And we've also got 2 workers here. And those are all assigned to the host names that we expect. We've also got Portainer agent deployed. And I'll refresh this in a minute because this is just doing it straight after it's deployed when it hasn't completed. But we should have the Portainer agent installed on each of these nodes, and then we should have the actual Portainer application itself deployed, which will connect to these agents and give us all the metrics for the respective nodes. And finally, we've got the Gluster pool here, which you can see all 5 nodes are connected, and the one that's localhost is just when I'm SSH'd into that master node 1, that's that one. So fingers crossed now, as you can see, Portainer's deployed. And if we connect to any of the IPs of these nodes, so it could be in my case 21, 22, 23, 24 or 25, and I connect on port 9000 or any port 9443 for example over HTTPS, we should be able to reach the dashboard. So let's do that now. So I'm deliberately picking a random node in the cluster, so I'm picking 22. Let's hit return. Yes, excellent. We've got the dashboard. And if I wanted to, why don't I copy and paste this and we'll choose a different IP address. So if I paste this and then let me change it to, I don't know, one of our workers, not our master node, do we get the same result? Yes, we do. So we know that that overlay network is working and we can connect to any node within the cluster and reach the same service. That's great. That's exactly what the high availability is underpinned by. So let me create a quick account here and then we can log in. So now having created that, and do bear in mind that if you wait longer than 10 minutes, you'll have to restart the service just for security reasons. If we skip this section here and just hit home, you can see here that we've already got the cluster assigned. That's because we deployed the agents and it's automatically connected to those. So we can see that it's 5 nodes. There's a couple of services running. There's 6 containers. And if we look into it, we get all of those details. So here's the 6 containers, and that makes sense, right? 5 agents, and then Portainer itself. So there's your 6. And if we click on Swarm here, we can look at all of the Docker nodes that are in there. So 1 to 5 tells you the CPU, the amount of RAM, the engine, and the IP address, etc., and the status and availability behind my ugly mug. And then you can choose to use Portainer as normal. So you can go to the stacks, and then you can create and add a new stack, Or if you want to do it through the command line, you can also do that. Now, you need to connect to one of your manager nodes if you want to deploy a workload, i.e. a service. And the commands to do that you can find on the Docker website. I'm not going to go into that exhaustively in this video. But basically, once you've done it for one, and you can see how we did that for Portainer, we simply downloaded the stack, and then we did the Docker stack deploy, and then we specified that YAML file and gave it a name. It's really that simple. And you can basically augment your existing compose files into a stack file. So the one for Portainer looks like this, and it's pretty much identical to a compose file. However, there's a couple of differences. One of the differences is the deploy section, and that's a bit like Kubernetes, or very similar to Kubernetes. So here we've said that the Portainer agent will deploy to anything where the OS equals Linux. So in this case, every single one. And that makes sense because we want the agent on all the nodes. However, for the actual Portainer itself, we've just specified that it will only deploy on ones that we call the manager. So that will only deploy on one of three. And importantly, there's also the replica count. So here you can see the mode is global. So that's going to deploy it globally on the cluster. So every node. That's why there are 5 and 5 nodes. However, down here we've said replica of 1. And that's because we only want one instance of this running. And typically that's a good idea because we only have a 1-to-1 ratio in terms of how we want to write to the folder. So we don't want multiple instances of Portainer all trying to write to the same location. That's just not going to work. It's going to break it because the data and the files are going to get corrupted because it's not designed to have multiple instances of Portainer writing to it at the same point. Or at least I don't think it is. And certainly that's what happens typically with homelab applications and databases, for example. So now you can basically replicate this stack, change it to your existing compose, and hopefully all you need to do is change the deployment and also the volume types. So for example, you want to make sure it's a bind, you want to use the source of mount, you'll need to create whatever folder you have. So imagine this is Pi-hole, for example, and then you would just tweak that accordingly and then deploy this file. So if we just jump in and test this by looking at each of the nodes within the cluster, and here I've checked the mount location for the Portainer folder. And thankfully on both 1, 2, 3, 4 and 5, we've got all of the Portainer files that we expect replicated to all of the nodes. So that proves that GlusterFS is working and thus we have high availability. So let's take that to the next level. Let's find out where Portainer is running, the management engine, and let's shut down that node and see if in the background we still have this up and running. So to do that, I'm going to open up a new terminal. I'm going to run a command just to check where it's running. And so if we run a Docker service PS on Portainer, you can see that it's running on Docker Swarm 02. So let's shut down Docker Swarm 02 and check if Docker then spins up on a new node. So here you can see I'm in Docker Swarm 02. So if I do a sudo power off, we now know that that's not going to be working because if we refresh this page in the background, you can see, yeah, the blue line's starting to go already. This service is shut down. It's not working. So let me just go back to this one here where we had it running and let's rerun that previous command. And now you can see that this one's shut down and it's now ready on Docker Swarm 01. So because it's already got that storage, fingers crossed, I can now reload this page. And yeah, we're back in. So it's as though nothing has happened. Portainer has now failed over to that new node and we can log in and all our data should be there. And hopefully we can test that our data is there and it's synced because these login credentials should work. And they do. Brilliant. So now we're here, we can see that we've still got the 5 nodes. I'm interested to see what happens when we click on that and go to Swarm. I assume that one of these is down. And yes, it is. We can see in the bottom right hand corner here that we've got Docker Swarm 2 and it's down. So there we go. We've got high availability in Docker Swarm and it's really simple. So I've been really impressed actually with Docker Swarm. Don't get me wrong, I'm already well on my Kubernetes journey and I'm not going to go back just because Kubernetes is far more advanced. But for a simple and quick and easy home lab setup, Docker Swarm ticks all of the right boxes. Especially when you've got something like a 5-node setup, you're going to get high availability with highly available storage, which is going to scratch the itch for most people of making sure that your services don't fall over. And for those who don't have the resources, it's also good. It's a lot more lightweight than Kubernetes. And also for those who are wanting to migrate from Docker eventually into Kubernetes, maybe that jump's too big, and this is a good halfway house where you can test and get familiar with failover, etc., test different things out before dipping your toe into the world of Kubernetes. So a big thanks for watching this, and anyone who tuned into my live stream where this didn't go too well. If you like this video, please give it a thumbs up, hit that subscribe button, and tell me below if this is something that you're going to use instead of Kubernetes. I think if you're in a single Docker environment, it really makes sense to check out Swarm because there's so many benefits to it. Anyway, take care everybody, and I'll catch you on the next one.